Okay. So I'm sure all of you have an idea of what is the term polymer, because it's a combination of many monomers. So polymers. So if you just look around and just think about your activities in the morning. So once we wake up in the morning, we want to brush our teeth. You have your, we'll use your toothpaste. The tube of the toothpaste that we use is actually made up of polymer. The brush that we are using is made up of polymer. When we want to rinse our mouth, we open you either open a plastic tap, for example, is a polymer. The pipelines used to bring water to your taps is again made up of polymer, which is polyvinyl chloride, or which is PVC pipes. You start preparing your breakfast, the non-stick tawa that you use is actually polymer. Non-stick means what? It is actually made up of Teflon. Teflon is a polymer, which is tetrafluoroethylene. I'll again write all of these as Teflon is a polymer. So polymers are actually something which we use in our daily life in huge manner from morning to night. The chair that we are sitting is polymer. The pen in which you're writing is a polymer. You know, all of these are polymers. And these polymers are, you can also call them as macromolecules. You can write down that polymers can also be called as macromolecules. These are, what do you mean by macromolecules? They're huge molecules because these are association of smaller molecules to give a bigger molecule, right? So we'll write polymers also are called as macromolecules. So what are these macromolecules? These are association of small molecules to give a bigger molecule. Macromolecules, for example, all these natural molecules are actually macromolecules, but this can also be man-made. So what happens here? The first synthesis was actually aimed to make substituents for natural molecules. We have rubber and silk, but then later we have hundreds of substances which don't have pure natural molecules. So synthetic macromolecules are synthetic macromolecules are elastomers. You know elastomers. These what are these? These have elasticity, like rubber. So elastomers are synthetic. They have this elastic characteristics of rubber. We have fibers, which are long, thin, thread-like structures. But with great strength. Like wool, silk, which characterizes like this, not exactly them, but which have characteristics like these. And we also have plastics, which are synthetic macromolecules. These are, you know, how do we use them? We use them as sheets, pipes, painted on surfaces, used for countless objects. So what do we do with all of these? With all of this, Polymers, what do? You try to wear these man-made materials. You try to eat and drink from them. We sleep between them. We sit and stand on them. We turn knobs, you pull switches, you grasp handles made of them. With their help, we try to hear sounds, and we try to see sights from us in time and space. We live in houses built by them. We move in vehicles that are made from all of these, right? We are just understanding how hugely we are using polymers in our day-to-day life. Now, these polymers, as I said, these are macromolecules, both natural and man-made. They have the great size. That's why we call them as macromolecules. They are polymers. That means many parts. Each one of them is made up of many simpler units which are identical to each other, or at least they have some chemical properties. They are normally joined in a regular way. So they are formed by a process like polymerization. With a process called polymerization, these monomers becoming polymers is by a process called polymerization. This is joining together of many small units to form large units. Simple compounds from polymers are called monomers. And polymers are actually classified, as I said, into elastomers, fibers, and plastics. This is based on their molecular forces. So let me write down the classification of polymers. We have classification of polymers based on different things. These elastomers, fibers that I spoke about are classification based on their molecular forces. So classification on the basis of molecular forces. So as I said, first of all, they are elastomers. It's important to know all of these. Elastomers. Elastomers are polymer chains held by weakest intermolecular forces. They're elastomers. So intermolecular forces. Because of the presence of these forces, polymer can be easily stretched by applying small stress and regain their original shape when stress is removed. These are elastomers. Next, we have fibers. These have strong intermolecular forces. Between the chains, the fibers are thread-like structures. But what are present? They are either hydrogen bonded or they have dipole-dipole interaction between them. Very importantly, they have high tensile strength and less elasticity. This is for B fibers. Second type under the molecular forces. Next, we have plastics, under which we have thermoplastic and thermosetting plastic. So under plastics, we are first talking about thermoplastics. Thermoplastics means they can be easily softened repeatedly when heated and hardened when cooled with little change in properties. See, the intermolecular forces here are intermediate. Means they are not so strong. Intermediate between elastomers and fibers. Means what? Elastomers are weakest and fibers are strongest. These are having in between. Next, we have thermosetting. See, these are all those which you might have heard at least once. Thermosetting plastics. In class 8 itself, you might have learned in fibers and plastics chapter. Thermosetting plastics means what? These undergo permanent change once you heat them. They undergo permanent change on heating. So, they have become hard and infusible on heating.
So, ma'am, if we heat it once or like cool it once, then
Thermosetting is like, how I remember is like thermo, heat. Once you heat it, it is gets settled. Then you cannot reset it. You cannot like reuse it.
okay.
Heating it, getting the plastic melted, again form a shape of our desired shape and all is not possible. But thermoplastics, it's like you make a toy out of it. You can easily soften it. Again, repeatedly, you use it for other purposes. But thermosetting is like they undergo a permanent change. Once you heat it in one shape, it's over. It becomes hard and it's hard and infusible on heating. So what happens here? When heated, they get highly cross-linked. See, highly cross-linked is like you have a link like this. So cross-linked is also there. Linear polymers are these polymers where you just have a link like this. These are linear. Cross-linked is you have one linear chain, another linear chain, they are crossly linked. So they get highly cross-linked to form hard, infusible and insoluble products. This is about the two types of plastics, and this classification of polymers is done based on molecular forces. Next, let us look at the classification of polymers on the basis of mode of synthesis. So we have seen three types. One is the elastomers, fibers, and plastics. We are now looking at the other classification. I hope everyone completed copying. You want me to go to the previous slide? I can go for anyone. Now, it's a classification on the basis of mode of synthesis. Classification on basis of mode of synthesis. First is an addition polymer. Addition polymer means this is, you know how it is formed, no? It is just formed by direct addition of repeated monomers without elimination of any byproduct molecules. The monomers are under additional. I'll show you how they are formed. Reaction also. These monomers are generally unsaturated. A double bond and triple bond. Okay, unsaturated compounds and are derivatives of ethene. like reaction. For example, you have NCH2 double bond CH2. They are going to polymerize as polythene. So these additional polymers, they have same empirical formula as that of monomers. The addition polymers, same empirical formula is the simplest formula. Empirical formula as their monomers. This is the first one. Second is the condensation polymers based on the mode of synthesis. I'll have to write it once you are done copying this part. Can I clear the screen? Is there anyone who's...
Yes, ma'am, you can.
Next, we have condensation polymers. Condensation polymers, what happened? This is formed by condensation of two or more than two monomers with elimination of simple molecules like water, ammonia, hydrogen chloride, alcoholic group. So it's just like if I have a phenol, I'm adding formaldehyde, 2 moles of phenol. I remove water and I have a byproduct. This is an example which helps you understand how this happens. And again, this on polymerization, by removing some n moles of water, we get bakelite, which is a polymer as the product. This is one of the examples of condensation polymer. So this much is about condensation polymers. Next, let us see how the polymers are formed. Different reactions. Let us look at polymers are formed in the following ways. In the following ways. First is chain reaction polymerization. In chain reaction polymerization, what happens? There is a series of reactions. There is a series of reactions, each of which consume a reactive particle and produce another similar particle. So what happens here? Each individual reaction depends on the previous reaction. So the reactive particles which I mentioned here, the reactive particles are like cations, they can be anions, they can be free radicals, anything. So let me look at an example, okay? We have a free radical and an ethene. We are going to have a radical attached and CH2 radical. This again in the presence of CH2 double bond CH2, we have a radical and CH2 radical, and so on and so forth. So it's going to continue like that. That's called chain reaction, where each reaction is dependent on the previous reaction and it will continue to happen. So I'm going to clear the second one. The second type of reaction is step reaction polymerization. Step reaction polymerization. I'm just keeping the reaction alone for those who are copying. Step reaction polymerization, what happens again? There is again a series of reaction. There is a series of reactions, each of which is essentially independent of the preceding one. A polymer is formed simply because the monomer undergoes a reaction. At more than one functional group. See what happens here, for example, is just to understand, a diol is going to react with dicarboxylic acid to form an ester. Okay, but each ester still contains a group that can react to generate another ester. So hence it forms a larger molecule. And again so on. So that is how stepwise the reactions are going to happen. I'm not writing an example because I just wrote the way it happens. So in this way, what the stearinine or dacron and all will be formed. Before I wrote, it's dacron, condensation polymers. I wrote bakelite. Similarly, it's stearinine or dacron will be formed. The third type is free radical vinyl polymerization. So I'm just clearing this. We have three. We understood how free radical works anyways, and we all know what is a free radical. So free radical vinyl polymerization. So we understood how the ethylene got polymerized and substituted ethylenes are all generated with the free radicals, I mean. So there is some initiator that is used to produce these. Same like other, free radical vinyl polymerization, same like other, what happens? So we have initiators for this polymerization, initiators like peroxide. What happens here is the reaction occurs at doubly bonded carbons. That is the vinyl groups. That's why it is vinyl polymerization. A wide variety of unsaturated monomers can be used to yield polymers with the different groups attached to polymer. For example, I have vinyl chloride. Vinyl chloride is going to form polyvinyl chloride, which is PVC. Similarly, I can tell you from acrylonitrile, which looks like CH2 double bond CHCN, we are going to have polyacrylonitrile, which is called Orlon. Third one I want to write here. from styrene, which is CH2 double bond CH, C6H5, we have polystyrene. These are from vinyl polymerization. Once we are done, we have copolymerization.
Ma'am, could you explain this once more? Free radical vinyl polymerization.
Okay. See, what happened here is we have initially, you know, how ethylene got under polymerization converted to same units like CH2, CH2, we just had some CH2 dash CH2 brackets N. Similarly, what happens here is the free radical vinyl polymerization means the method that they used in this polymerization is free radical technique, where the like bond breaks, right? Here the double bond got broken, and that you have one electron here, one electron here. That's where it's forming one more bond here and one more bond this side. Okay, so vinyl are those which have double bond and two C's, and to the C one more some group is attached. So here it is vinyl chloride. So vinyl chloride underwent normal polymerization, and we have the same monomers combined and form polymers. Like exactly same monomer units are combined here like this. So we're just calling them as polyvinyl chlorides.
Okay.
Yeah. Next, fourth one is copolymerization. This is the last technique. Copolymerization means so far what did we discuss? We only discussed about single monomeric compound. It's forming a homopolymer, like same units. So a polymer made up of course, like two different things of identical units. That's what we used. Now, if a mixture of two or more monomers are allowed to undergo polymerization, then there is a copolymer which contains two or more kinds of monomers in same molecule. I'll show you an example. For example, CH2 double bond CHPH is a styrene. If it is combined with CH2 double bond CCH3 COOCH3, it is methyl methacrylate. And you added some initiators like some peroxide. You're going to have this is polystyrene and co-methyl methacrylate. The co is to just tell it is a copolymer. So copolymerization is we're just using. So far we've been using homopolymers and a single type of polymers. But here we combined two different monomers and had a polymer. It's the combination. This is copolymerization. Next, we'll understand about some common polymers in detail. I'm clearing it. Next we have natural rubber. Natural rubber. So natural rubber is an addition, very important, okay? It is an addition polymer of iso. What is isoprene? This name is 2-methyl 1,3 butadiene. Okay. This rubber, it has an average chain length of 5,000 monomer on average. Monomer units of isoprene. Okay. So when you have arrangements in the rubber in which there is an arrangement of carbon chain is trans with respect to the double bond. You know what is cis and trans. Then you call this as GUTTAPERCHA. This is the natural rubber. That is from where are you getting? From barks of trees. You know natural rubber is sticky material. And you know the recent part is removed by vulcanization. What? Vulcanization is what? Addition of sulfur to rubber and heating. That's called vulcanization. So sulfur, it forms short chains of sulfur atoms that links two isoprenes together. This sulfur only, it links two isoprenes together. And you know the natural rubber, it can be stretched to only certain extent. And the hydrocarbon chain, they have the tendency to regain their shape when you put some stress or anything. So what happened? Vulcanization is done to remove the stickiness of rubber. So vulcanized rubber is more stronger when you compare it with the natural rubber. This is natural. Let us now understand synthetic rubber. First, natural rubber we understood. I'm clearing the screen. Can I? Is there anyone who's still writing? Synthetic rubber. Synthetic rubber. Synthetic rubber is actually polychloroprene or it is made up of neoprene. And how is this obtained? This is obtained by free radical polymerization of chloroprene. Of chloroprene. So you can see there are n units of CH2 double bond CCl, CH double bond CH2. We are polymerizing it into the neoprene because it is another isomer of. And synthetic rubber, it is thermoplastic and this need not be vulcanized because it is not natural. It doesn't have the natural stickiness. And this is superior to natural rubber. Why? Because this is resistant to other external reactions, like it is resistant to air, resistant to heat, to light, chemicals, alkalis, acids, everything. And what do we use this for? For transmission belts, printing rolls, and flexible tubing, employed for conveyance of oil and petrol. This much about synthetic rubber. I'm clearing it. Okay, please ask me to show if you have not copied. Next, we have Buna rubbers. This is the last type of rubber. Buna rubbers. Butadiene polymerizes in the presence of sodium to give a rubber substitute which is Buna. And this Buna has two types. One is Buna N. The other one is Buna S. Buna N and Buna S. This is obtained by copolymerization of one part of acryl nitrile and 2 parts of butadiene. It is more rigid. It responds less to heat and very resistant to swelling action of petrol, oil and other solvents. Tuna S is a copolymer of 3 moles of butadiene and 1 mole of styrene, and it is an elastomer. We got this as the product when there was free polymerization, free radical copolymerization technique. So this is generally vulcanized. It is vulcanized with sulfur. We use it in the manufacturing of tires. Sorry, tires. That's it about 3 types of tire. Sorry, rubbers.
Ma'am, we're not done with the chapter though, right? Or are we done?
We're not done with the chapter. We have we have Teflon to understand with nylon. We have we have to still talk about, there are around 20 polymers that I have to give, which we have to understand 20 types of polymers, their monomer units and uses. So we'll be done with
Okay, ma'am.
in one more class. I think the polymers part will be done.
Okay, ma'am.
Yeah. So once you're done with this rubbers, we'll end the session, and I will, in one more class, we'll be completing the polymers chapter. I'm going to complete metallurgy and also coordination compounds maybe in the coming 2 or 3 weeks. Metallurgy and coordination compounds is not done for you, right?
No, ma'am. No, ma'am.
Okay. Because I know there's other simultaneous class that's going on, so I just thought I'd ask. Okay. Thank you all. Whoever has copied this part can leave the class. Whoever has not can copy it, then leave the class. Is there anyone who's still copying?